Precalculus review of algebra prior to calculus part 1. In going into calculus, what we have to do is bring to bear what we've learned prior to being in calculus class, and we're going to review some of these important concepts. A lot of times, the hardest part of the calculus course is not that dealing with the principles of calculus themselves, but the algebra, the manipulation, the simplification that goes with and makes the tool of calculus more feasible. So we're going to use some rules of exponents to simplify some expressions. Here we have 3x to the negative 2 power times 7x to the negative 2 power. So what we're going to do is take 3 times 7, which is going to be 21, and then we have times x to the negative 2 power times x to the negative 2 power. Well, we're going to use our product property of exponents, and we're going to add exponents. We're going to get 21 x to the negative 4 power. And then using the rule of negative exponents, this x to the negative 4th power in the numerator can be brought down into the denominator as x to the 4th power. And so either method would be okay. Now usually it's by convention, we tend to go with leaving the exponent to a positive power, so this one on the right. But then we have to look at what would be excluded. What are the excluded values of the expression? Well, we know our denominator cannot be equal to 0 because we can't divide by 0. So we can write also x is not equal to 0 because that's not permissible. Okay, now we have a similar looking problem, but instead of multiplying as we did in part A, we're subtracting. So we're going to rewrite this 3x to the negative 2 power as 3 over x squared. And again, x cannot equal 0. Now we're going to subtract 7 over x squared. Now these are both like terms, so 3 minus 7 is negative 4. So we have negative 4 over x squared. So really, that's going to be it. Next we go to problem C. We have a fraction, x to the negative 2 power plus 1 over x minus x to the negative 2 power. This division bar what that division bar does, it implies that both what is the numerator and the denominator are like in parentheses. So I'm going to rewrite this expression here, this x to the negative 2 power, I'm going to rewrite as 1 over x squared. And so we're going to have the numerator 1 over x squared plus x, and the denominator we have x minus 1 over x squared. And so we want to get a common denominator for both the numerator and denominator, and I'm going to put both of these over x's over 1. And our common denominator is going to be x squared. And so just working the right, we have in the numerator 1 over x squared, and then we have plus, we have x. Now what do we have to multiply by? The denominator to get x squared. We have to multiply by x squared. And likewise, we have to multiply our numerator by x squared. And so now we go down to the denominator. We have x over 1. What do we have to multiply by? Denominator x squared, and likewise the numerator x squared. Then we have minus 1 over x squared. Now we can rewrite this expression using the single denominator of x squared. So we have 1 plus x times x squared is x cubed. And that's going to be over x squared. And then our original division bar, we have x cubed minus 1 over x squared. And what do we do when we divide by a fraction? Well, I hope you remember from someplace in your math career that dividing by a fraction is the same as multiplying by its reciprocal. So we're going to rewrite this expression here. And I'm going to change this up a little bit. Instead of writing 1 plus x cubed, I'm going to make this more in what we call a standard form, where we put the greatest power term first. So rewrite 1 plus x cubed as x cubed plus 1. And we're dividing that by x squared. And now we're going to multiply by the reciprocal of this fraction below. So we have x squared over x cubed minus 1. And so what we have now is a cancellation. So working below, we have x cubed plus 1 over x cubed minus 1. And one thing I didn't do earlier was find our excluded values. Well, we noticed initially when we started working out this problem that we're divided by x squared. So we know that x cannot equal 0. And we also know that our denominator in our final result, x cubed minus 1, cannot equal 0. So therefore x cubed cannot equal 1. And then taking the cube root of both sides, x cannot equal 1. So we have our exclusions and our final answer here. Next, D. Okay, we have this expression here, this rational expression, negative 2x squared times y to the 4th power over 3y to the negative 5th power. What we're going to do is use our quotient rule of exponents to simplify inside first. And so we're going to rewrite, take care of this y business here. So we have negative 2x squared over 3. Okay, now using our quotient property of exponents, we have y to the power of 4 minus negative 5. And what is 4 minus negative 5? Well, it's going to be 4 plus 5 or 9. So we're going to have y to the 9th power. And then we raise that to the power of negative 2. And so just continue to work to the right. We're going to distribute this power of negative 2 to everything inside the parentheses here. So we have negative 2 to the negative 2 power, and we have x to the negative 4 power. Negative 2 times 2 is 4. We have y to the negative 18th power, and then we have, down in the denominator here, we have 3 to the negative 2 power. Now, we have negative exponents everywhere, so to get rid of our negative exponents everywhere, what we have to do is multiply by, or just swap on the division bar. So everything that is above in the numerator, we can make it the exponent positive by dropping below. So what we have here is this negative 2 to the negative 2 power becomes negative 2 squared. Okay, this x in negative 4th power in the numerator becomes x to the 4th power in the denominator. And this y to negative 18th power becomes y to the 18th power down here in the denominator. And then this 3 to the negative 2 power becomes 3 squared up above. And just working below, what we have is, in the numerator, 3 squared is 9. In the denominator, we have negative 2 squared is 4. And we have x to the 4th power, y to the 18th power. And as far as what our excluded values are, x cannot equal 0, nor can y equal 0. Okay, so that takes care of that one. Next, e. Okay, this expression here, 3 to the 3x power times 9 times the power of 3x minus 2 times 81 to the power of x over 27 to the power of x plus 2 over square root of 3. What we're going to try to do is rewrite this expression in a common, each one of these numbers as a common base. What base do we have in common with all these numbers? So I hope you can see that 3 would work very well. So we're going to try to rewrite this whole expression as a base of 3. So first of all, we write 3 to the power of 3x. That's unchanged. Now, how can we rewrite 9 as a power of with 3 to an exponent? Well, 9 is the same as 3 squared. So 3 squared to the power of 3x minus 2 times, now 81, how can we rewrite that as a power of 3? That's going to be 3 to the 4th power times x to the power of x. And down here in the denominator, 27 we can rewrite as 3 to the power of 3. We have here outside the power of x plus 2. And what is the square root of 3? Well, it's going to be 3 to the power of 1/2. Okay, so next thing we're going to do is use our distributive property to get a common base here. So we have 3 to the power of 3x. We have 2 times 3x minus 2. So that's going to be times 3 to the power of 6x minus 4. And then we have times 3 to the power of 4x. And now what we have is we have in the denominator 3 cubed, and what that's going to do is when we bring the power up here, I'm just going to rewrite this as up here, 3 to the power of negative that'll be 3x plus 6. That'll be 3x. Actually, let me write that to make it a little clearer. We bring this up here. We have negative 3x. Oops. Plus 6. And finally, we have this times 3 to the negative 1/2 power. And so now, working below, we're going to try to combine everything. So we have 3 to the power of 3x plus 6x minus 4 plus 4x. We have minus 3x minus 6 minus 1/2. And now we're going to simplify. So we're going to have 3 to the power of 3x plus 6x plus 4x. So 3x plus 6x is 9x, plus 4x is 13x, minus 3x is going to be 10x. And then we have minus 4, minus 6, minus 1/2. Well, minus 4 is going to be negative 8/2, and minus 6 is going to be minus 12/2. And then we subtract out 1/2. We get negative 8 minus 12 minus 1. We're going to get negative 21/2. So we're going to have minus 3 to the power of 10x minus 21/2. And that is going to be our answer here. Okay, let's go on to look at simplifying rational expressions. In rational expressions, we're going to do a couple things here. First is we're going to look at our excluded values. We have 4 over x plus 2 plus 3 over x plus 6. So we know that x cannot equal 2, nor can x equal negative 6. So what is our common denominator going to be? Well, our common denominator is going to be found by just multiplying these two denominators together. So we have x minus 2 times quantity x plus 6. So now let's rewrite this fraction above here. So we have 4 over x minus 2. And what do we have to multiply by x minus 2 to get our common denominator? We just have multiplying by x plus 6. So we have x plus 6 here. We have plus 3 over x plus 6. And we multiply the numerator and denominator both by x minus 2. And working to the right here, we have distributive property. We have 4x plus 24. Then we have plus 3x minus 6. And that's all going to be over this quantity x plus 6 times quantity x minus 2. And then simplifying and finishing this problem, we have 4x plus 3x is 7x. And then we have 24 minus 6 is 18. Then we have x plus 6, x minus 2. And so that would be it. And we have our excluded values and everything. Okay, next, B. Okay, we have our denominators here for each of these fractions. It looks very similar. We have quantity 2x plus 3 cubed, and then quantity 2x plus 3 squared. So what is our common denominator going to be? Well, our common denominator is going to be the higher powered denominator, this one here. So it's going to be quantity 2x plus 3 cubed. And then as far as what our excluded value is, we cannot divide by 0. So we know that 2x plus 3 cannot equal to 0. So if we subtract 3, we get 2x cannot equal negative 3. So x cannot equal negative 3/2. So that would be our excluded value here. Now to work out this problem here, to simplify, we're going to rewrite this first fraction and do what to it? Absolutely nothing, because that's going to be, we already have our common denominator. So plus 1 over 22x, 2x plus 3 squared. Now what do we have to multiply? this by in the denominator, we have to multiply by 2x plus 3. Okay, so, and what we have to do in the numerator here, we have to also multiply by 2x plus 3. So what we have here is negative 4 plus 2x plus 3. And this is all over our common denominator of quantity 2x plus 3 cubed. And combining like terms, what we have here is 2x minus 1, okay, because negative 4 plus 3 is negative 1. So we're going to have in the numerator 2x minus 1. In the denominator, we have quantity 2x plus 3 cubed. So that is going to be our answer. Okay, next, C. We're going to go ahead and try to find a common denominator by looking at these two quadratic trinomials in each of these fractions. So we're going to take this first one here, x squared minus 3x minus 18, and see if we can find the factors, the linear factors of this quadratic trinomial. Well, factors of x squared are going to be, of course, x and x. And then after that, we ask ourselves the much needed question, what two numbers do we multiply together equal negative 18 but add together to be 3? Well, I think 6 and 3 are going to be what we're looking for here. And we have negative 3, which means our 6 is going to have to be our negative, because that's have to be our bigger number. So this would be our factored version. So we know from this already that x cannot equal 6, nor can x equal negative 3. Next, we have x squared plus x plus 6. And then when you have something like this, one thing you'll usually find is that one of these linear factors is likely to be the same as one of these two factors already determined from the first expression. That's going to help in our simplification. So just something to look out for. That isn't always the case, but is often the case. So we have x squared is going to be x and x. And what are our factors of 6? Well, they're going to be 2 and 3. And 3 is going to have to be, to make x positive, 3 is going to have to be our larger number. So we have quantity x minus 2 times quantity x plus 3. So we also know that x cannot equal 2. Okay, so let's go ahead and rewrite this expression here. So we have 5 times quantity x minus 6, quantity x plus 3, and we have to multiply both. So our common denominator, I didn't write that down, is going to have to be x minus 6 times quantity x plus 3 times quantity x minus 2. That's going to be our common denominator. So let's go ahead and multiply this denominator by x minus 2 and multiply also our numerator by x minus 2. And we're going to add 2 over, we have this quantity x minus 2, x plus 3, and we have to multiply by x minus 6 to get our common denominator in place. So we have x minus 6. And now we can distribute through. So we have in our numerator here 5x minus 10 plus 2x minus 2 times 6 will be minus 12. And that's going to be all over quantity x minus 6 times quantity x plus 3 times quantity x minus 2. And combining like terms, we have 5x plus 2x, which is 7x. And negative 10 minus 12 will be minus 22. And then that's going to be all over quantity x minus 6 times quantity x plus 3 times quantity x minus 2. So that is that problem worked out. We have our excluded values in place. Next, D. Okay, so we have a little level of complication. Now, one thing we have is on the right here, we have this 16 minus x squared. I'm going to see if we can rewrite this so we can have this just a positive x squared. Well, that's going to be equal to, same as negative 1 times x squared minus 16. Okay, so let's go ahead and do our rewriting. Well, I'm going to do something else first. I'm going to look at this x squared. Let's go ahead and factor this x squared minus 16. So we have x squared minus 16. We could factor using a difference of squares. That's going to be quantity x plus 4 times quantity x minus 4. And then our other denominator here is going to be x squared minus 5x plus 4. And that's going to be equal to x. We're going to have negative times a negative. And that's going to have to be 4 and 1. So we know that x cannot equal 1. X cannot equal 4. X cannot equal negative 4. Let's go ahead and continue writing this out below. So we have in the denominator, we have quantity x minus 4 times quantity x minus 1. And then in the numerator, we have 3x minus 3. Now, one thing that can be difficult to watch out for, you look for things you can do. We can rewrite this 3x minus 3 as 3 times quantity x minus 1. Okay, so that gives us an opportunity to do this, doesn't it? And then we're going to have minus 4 over negative, because we have this negative here, negative, I'm just going to rewrite this as x squared minus 16. And our minus will cancel each other here. So I'm going to continue to work below. We're going to have 3 over x minus 4 plus 4 over quantity x plus 4 times quantity x minus 4. And then we're going to rewrite this 3 over x minus 4 as 3 And what do we have to multiply by to get our common denominator? Let me just write down our common denominator at this point. Common denominator is going to be quantity x plus 4 times quantity x minus 4. Now, if you didn't catch to be able to cancel out this x minus 1, you could have continued to work through and still got a somewhat correct answer, maybe not quite as simplified. So we're going to have to multiply this first fraction by quantity x plus 4 plus 4 over x plus 4 x minus 4. So now just work to the right. We're going to have 3x plus 12 and then we have plus 4 over quantity x plus 4 x minus 4. And then combining like terms, we end up with 3x plus 16 over quantity x plus 4 times quantity x minus 4. Okay, really, so that's going to be it. Okay, the last one to look at here, you have these fractions in place. The first thing I hope you notice is that if we cannot divide by 0, what can y not be? Well, y cannot be equal to 0. So that's going to be our excluded value. So what we're going to do is look for common denominators both in the numerator and the denominator. Well, in the numerator here, I'm going to write a bar here. Our common denominator is going to be 6y because 3 is included within that 6, right? So I'm going to rewrite this 2/3 as 2/3. And what do we have to multiply to get 6y? We have to multiply by 2y in the denominator and also here in the numerator. And so we're going to have minus 1 over 6y here. And that takes care of our numerator. In our denominator, what is our common denominator going to be here? Well, 5y times 3, or 15y. So we have 1 over 5y. And what do we have to multiply by to get our common denominator? We have to multiply by 3. And then we have plus 2 over 3. What do we have to multiply by? 5y. Both the numerator and the denominator. And so working to the right here, we're going to have 2 times 2y, or 4y, minus 1 over 6y. And down here in our denominator, we're going to have 1 times 3, or 3 plus 10y, and that all over 15y. And what do you do to simplify? Well, multiplying or dividing by a fraction is the same as multiplying by the reciprocal. So we're going to multiply by the reciprocal of this denominator, which is going to be 15y over, and I'm going to rewrite this 3 plus 10y is 10y plus 3. And y and y are going to cancel each other here. And then 15 over 6 is going to simplify to 5 over 2. So I'm going to rewrite this as 5 over 2. So just working below here, we're going to have 4y minus 1 times 5 over 2 times 10y plus 3. And then we could distribute if we want to. I'm just going to write this in a prettier fashion here by putting that 5 out front. So we got 5 times quantity 4y minus 1 over 2 times quantity 10y plus 3. And that's going to be our answer. But do you notice anything that we still need to take care of? We have a new expression in the denominator in terms of y. And since we're not able to divide by 0, we also know that 10y, I'm just going to do that below for clarity's sake. So below 10y plus 3 is not equal to 0. So 10y is not equal to negative 3. So y cannot equal negative 3/10. Okay, so that's really going to be it. Again, we're just reviewing as part of previewing to go into calculus these tools of algebraic manipulation, rules of exponents that can be helpful to you, that you're going to need going forward. Good luck, and thanks for viewing.